Good afternoon, ladies and gentlemen. So my name's Chris Wiltshire from John Deere, and I'm maybe just going to spend in the next 25-30 minutes or so just really talking around how John Deere as a company is having its little input into maybe adding technology into a lot of the farm equipment that we're producing today to make farming more sustainable. So I guess sustainability and farming or sustainable farming has definitely been a big part of the whole agenda of many of the speakers today and even over the whole event. So there are lots of my colleagues, many of the sponsors of this event that can probably talk a lot more detail on actually the detail or the science behind the sustainable farming. But maybe myself just give a little bit of a snapshot on where Deere is putting some of the technology. Okay, so maybe we'll just set the scene. Have we got any farmers here? No? Right, great. Well, one thing for certain is farmers are fantastic people. So, you know, if you look at what their role today as far as producing food for each and every one of us, point blank. So that is a pretty tough job today. Because guess what? There's more and more of us. And actually, the resources that farmers rely on, whether that be the amount of land, whether it be the soil, whether it be the water they use, becomes more and more precious. So farming is a very challenging role today. So today we have to put more and more support to farmers to be able to do the job that they need to do. Farmers are also responsible today for helping to produce some of the energy that we provide. So not only food, but also energy crops. So again, they're a big part of our future as far as where we will get as the source of our energy. And of course, farmers are also the custodians of the land that they manage. So the environmental pressures that farmers now need to work towards are absolutely key. So all of those things put together do make those farmers pretty special people. So thank a farmer. If you get the chance to visit a farm, then please make sure you do that. So where does John Deere fit into all of that? Well, we hope that we provide a lot of solutions and services and tools to make farming easier, more efficient, more sustainable, and help to increase farmers' daily life. So I'm going to try and touch on three key areas of technology that we're building in and around our products that are helping farmers today. So I'm going to talk a little bit about electrification. I'm going to talk about site-specific farming. And then I'm going to just throw a bit of a curveball in at the end with a little bit about autonomy that's going into farming as well today. All right? So if we start with electrification. So each and every one of these machines that you've seen, there's a green machine, there's a grey machine out behind, have all got one of these in the heart of it. And guess what? Farm machinery today has to work pretty darn hard. So generally these things are pretty big motors. They're using a lot of fuel to do the daily job that they need to do. And why do they need to be that big and that strong? Well, again, farmers are challenged with smaller working windows, the challenges of the environment and the weather windows that they work within, to ensure that we harvest at the optimum time. All of these things ensure that we have to get the maximum productivity out of the farm machines that are being used today. So we do need highly productive machines working in the field. But guess what? Just like all of our cars at home, a lot of the buses and transport systems that we're using around our daily life, we're under the challenge of reducing the use of fossil fuels. So we're trying to reduce the amount of diesel engines that are within our vehicles. So we have to look at what other sources of power there are available to us. And just ourselves and many of the other manufacturers around the agricultural industry, we will all be looking at different fuel sources. And today, diesel engines would probably be one of the most power-dense engines that is available. So if we look at whether it be the tractor or the combine, they're working on maybe a 10, 12-hour working day. The fuel that is in the tank will produce 100% of the energy that machine would require. If we were to try and convert that machine to a different power source, maybe using a biodiesel, we would actually lose some of the power density that would be available. So if, for my simple maths, if in a diesel machine it could do a 10-hour day, if we use a biodiesel, it may only do a 9-hour day with the available fuel on that vehicle. If we bring that into either a methane application, we may only get 2 hours of operation out of that tractor. So of course that starts putting different challenges into farmers of how do I do all of my work using maybe a reduced power source. And of course something like hydrogen may be even less. One of the big focus areas in many of the vehicles that are around us today is of course battery. But the power density of battery right now with the technology that is available is also challenged. So again, we cannot get maybe the 10-hour day from that vehicle using batteries. But we maybe need to offset with, the benefit in the emissions that those vehicles would give. So again, a diesel engine, we're getting no emission benefit, no CO2 avoidance with a diesel engine. With a rape or biodiesel, we do get a high level of CO2 avoidance. Likewise in methane we do, and in hydrogen, but of course the greatest CO2 avoidance that we could have is through a battery or through green electricity generation, where we charge batteries using either solar or wind, and then we make that power available to our vehicles. So guess what? As Deere, we are looking closely at what we can do around the electrification of our vehicles. To start with, it could be some sort of hybrid vehicle. So today we have vehicles that have diesel generation, electric drive, so that could be the first step in our electrification of vehicles. But also it would actually be quite easy for us to introduce a range of products that would be very sustainable in a battery application. So maybe our smaller range of tractors, maybe not quite the large tractor that we've got in the corner here, but maybe we start with some of the smaller products that we have, and they could be fully electric within the next couple of years. And guess what? To help us along this journey, we've actually just bought a battery company. So an Austrian company called Kreisel. So any of you that's been on one of the electric buses around London, it's actually got a bit of John Deere inside it. So that's actually a John Deere battery in it today. So again, you can see that the focus of a company like ours, and many of the other companies, it's not unique to John Deere, is that we are looking at different solutions to propel our agricultural vehicles going forward. So that's a little bit about electrification. My second point was site-specific farming. So today, farmers are using an awful amount of technology to record what they do. We've actually had what we call precision farming. We've been able to measure the amount of yield from a wheat field for the last 25 years. So farmers have been able to measure the amount of yield that they've been able to do for that amount of time. The tricky bit is, what do we do with that information? And I think it was one of the speakers earlier actually made reference to that. So actually using the data that is available to farmers today to actually make them more productive in what they do and making them more sustainable. So it's not only about the yield that we're interested in, but it's actually about the quality of the yield that we might be harvesting. Depending on the crop that we are harvesting, it all makes a massive impact on maybe how or the fields that we choose, the chemicals we apply, the fertilizers we apply, or even the seed choices that we may want to use. So using the right amount of information, farmers can make those defined decisions to ensure that they absolutely offer the greatest productivity from their land that's available. And of course, there's so many things that have an impact into the output of each and every field. So the soil below, the weather conditions above, what we're actually putting onto that field. So today, again, we are adding systems and tools and technology that's not only measuring the amount of grain that may go through the combine, but we use a near-infrared sensor and we can actually measure the protein of the grain coming off of that combine. So grain is grain, but no, it's not. The grain that we have or we can harvest may be more applicable for different uses. Is it best for milling? Is it best for feed? And this could all be determined by the protein level that we can measure within that grain. A field can yield different levels of grain across it and can have different protein levels across the grain that we can harvest across that field. And the scientists behind me will tell you far better than I will that having detailed maps of the quality and yield that we are harvesting from each and every square metre of the field can really determine how we work or how we apply chemicals, not only to get the maximum productivity, but also the maximum efficiency for those yields in the field. So again, it may be that we are over applying some of the inputs into that field. Maybe we don't need to put as much into the field, or maybe there are areas of the field that we need to pay a little bit more attention on. So again, with clever and accurate measurement of what we do, not only in yield, but in proteins and starches and the oil content of oilseed rapes, all of these things that can be measured can really determine and ensure that farming is doing it in the most sustainable way. So that really does just bring right back to our site-specific farming. So we have gone away from just mass applying either fertilizers or pesticides or seeds or herbicides across an entire field. With the technology that is available today, we can actually manage what we do on a square meter size or area, or actually in certain applications we can even get down to plant-based applications of chemicals and fertilizers. So again, we can really drill down and get the detail onto the field. Many modern farm machines have this technology built into it today. So this isn't future stuff. This is what is available today. It's just actually managing the data that we have and ensuring that we are doing the very best per field, per crop. Where this will go in the future, we will see this develop further into what we call see and spray. So we'll have vehicles that are actually looking real time at the crops and applying either fertilizers or herbicides, pesticides as they travel across the field. So again, really ensuring that we are managing to that site specific area. I'll skip through that one. So my final sort of look at where we as a company are trying to add more technology to support our farmers. And again, it was a touch point in one of the conversations earlier with regards the availability of people within our industry. We've got an aging workforce or an aging farmer base, and actually it becomes more and more tricky to get people to do the jobs that are required in that ever smaller working window. So again, the climate changes that we have seen, we are seeing that jobs need to be very time specific, and actually being able to do those at the right time with the right people gets harder and harder. Autonomous machines today is a major focus area. It takes away the operator error in so much of what we do. It allows a vehicle to actually work potentially 24 hours a day. And today, we have fully autonomous tractors that are available from John Deere. So at the moment, it's only available in North America. There's some legislation changes that need to happen within Europe for us to be able to have them a little bit closer to home. But we will see this come into the market where we will have fully autonomous tractors to support our farmers. So again, it can help to reduce the mundane operation. It can ensure that we're absolutely doing things on a time-dependent way, and ensure that we can absolutely improve the productivity of our farmers out there. So I guess from a couple of things that we've just seen there, where does that maybe lead even to the next step? Well, potentially we can have a fully autonomous battery vehicle, and maybe we don't need any type of operator station. And we again are testing equipment like this, and it is something that is probably not that far away in the real term. So again, you might be driving down the road looking over a field or hedge, and you might see something like this in the near distant future. So that's maybe where our future space for equipment may be going. So hopefully that's given you maybe a little bit of a snapshot on some of the technology that companies like ours are investing in the products that we're offering. It's showing a direction of travel of where equipment will go to support our farmers, and hopefully again it's there to ensure that farming today will become more and more sustainable, to ensure that we can provide for our ever-growing population using the resources that we have in the smartest possible way. So that was my short little presentation. Any questions from the audience, from anybody? Yes.
Well, one of the things we've seen is in robotic machines for picking and strawberries and so on. That's obviously needed given the limitations of workforce. Is that something that John Deere is involved in and looking at?
Yes, it is. I would say high-value crops is a very much a focus area for us right now. So how we can fit into that production system, we would call it. Robotics will play a big part in that going forward. So some of these fully autonomous vehicles, specifically battery, will probably be one of the first vehicles that we will see for those high value, whether it be used in vineyards or grapes or whatever it might be. So that will definitely become very, very soon. Yes. So it is in the public domain. We have committed that by 2026 we will have a fully autonomous battery vehicle in high value crop applications.
Somebody else had their hand up earlier, didn't they? Yes, sir.
Thank you for the presentation. You talk about the legislation in US is already possible to have autonomous vehicles, and you talk about changes in legislation in Europe. Can you say something more? I mean, what's expected there?
I think I'm not an expert in the detail behind that, but my understanding is that there's just not a clear framework of where that would sit, even with all of the health and safety requirements. Just the guidance that's needed to be behind it as a manufacturer to produce that machine. So there's still a little bit of work required.
Is it the same barriers preventing companies launching driverless cars on the road, for example, or the absence of legislation?
It is the absence of legislation, yes. Yeah.
I'm sure I saw another hand before today. But maybe just expand on that a bit further then. If legislation is the primary barrier rather than technology, do you think within our lifetimes then, Chris, sort of driving as a skill is going to be sort of become something like handwriting is today, sort of a nice to have but maybe not essential then?
I think you always need to write something, and I'm sure there will always be a tractor application that you'll need to drive. So it's never going to be a skillless industry. So I think we don't need to worry about that. But I think what it will really show is that we can really drive productivity through the challenges that we have with getting the amount of people and the right amount of people in our industry. So there's always going to be a requirement. It maybe just needs that we'll have one highly skilled person that could maybe look after 2 or 3 tractors, whereas today, of course, it's 1 per vehicle.
The massive push factor with the challenges about access to labour in agriculture at the moment. You had
Absolutely.
your hand up again, sir.
You mentioned that the autonomous tractors are already operating in the US, so they must have a legal environment in which that's possible. So imagine a scenario in which your autonomous tractor goes out of control, ruins somebody else's field, ploughs a furrow through the local freeway.
Yep.
Who is responsible? Is it the farmer? Is it John Deere?
That's a very good question. I would imagine if there's anybody from an insurance provider, that might be a little bit of a.
But this
an
must be
interesting
set
question.
out in law, mustn't it?
I guess that will be. We've not. There's probably no precedent of how that has gone yet, but yet, but yes.
It's a very interesting case law. We'll come here. And
Hi, when you say autonomous, do you mean completely not connected, or have you got some?
So the way that it would work is it's a standard tractor, similar to the one we've got over here. It has 6 pairs of stereo cameras around it, and it's gone through intensive training to learn the application it is defined to do. What it is doing at all times is it's connected back to a single person. So if it sees something that is out of scope, it might see a rock or a stick or a something, and if it doesn't recognize what it's learned over its training, then it will stop. It will notify the person who's responsible. It actually sends them a picture and says, "What is this? Can I drive over it?" And the operator then can say, "Yeah, it's fine," and they drive over
So
it.
from the last National Farmers Union survey on connectivity, only 17% of farmers said they had connectivity across their whole farm outdoors. So will the tractor run over to a bit of the field where it knows it can get a signal?
I guess that's one of the challenges around having a connected farm and having whether it be 4G, 5G network available. So connectivity could be one of the barriers as well going forward. Right. Okay.
Yeah. Is John Deere working only on technology or also on the analysis of the data? Because when you go on the field and you have to put some pesticide here and not there, okay, you have to collect data and also to analyze and give back the information to the machine. Is John Deere working on all cycle of this?
So there will be people working on that, but I think if you look at who and what we are machinery manufacturers. We're pretty good at it, and we can put an awful lot of technology in. There are other people with other skill sets that can probably analyze that data better than we can. And I think this is one of the important points, and again, it came up earlier, is what do you do with the data? And I think that's one of our wishes, is that whatever data is being collected, we make it freely available to the right people. So again, the data belongs to the customer, and the customer then can choose who maybe sees that data, and they can analyze it. So it could be you may be the right person to make the decisions on what they're seeing from that yields, that harvest, the protein levels, and whatever. You then can feed back into what we call our operations center, and the farmer executes on your support and guidance. So you're probably in a better place for the agronomic decision making than we would be. We'll want to give you the tools, you make the decision, and then we'll execute what you want us to do. So we're trying to make it as open as possible for as many people to have an input into that decision making.
One thing that is under your control is the choice then over future fuel uses, which you started your presentation on. Is John Deere making a strategic bet down one alley or another, or are you trying to, I suppose, innovate in all methane, hydrogen and electric at the moment?
We've not set our stall out for any one. I guess we've probably focused more on electrification because long term I think that's probably going to be more of a direction, but everything is on the table right now. So yeah, we'll wait and see what filters out.
Yeah, big debate for the future, that one
Yeah.
too.
I noticed at the end of your video on the autonomous machine that you had a couple of signs of your partners who'd been working on this, and I couldn't quite see who they were. They look like German organisations. Who are they?
Yeah, so one of our key engineering centres is in Germany. So one of our second largest factory in the world is based in Mannheim in Germany. And so we will work with a lot of the German research organisations, whoever they may be. So
Would it be like the Max Planck Institute or the Fraunhofer Institute? Or?
yes, I can show you who they are afterwards. Yeah. Yeah.
Any more questions for Chris? The one thing, perhaps a positive note to end on, Chris, is perhaps that he maybe underplayed the positive case of autonomous tractors in one area is the fact that they are likely to be much smaller, aren't they? And that will be hugely beneficial in terms of compaction and protecting the soil.
Absolutely. So soil is such a resource or vital resource that farmers have today. The tractor that we've got here, you know, we still need high horsepower tractors for the productivity of modern day farming, but of course how we support soil going forward is absolutely key, and our 8RX there is one of those key differentiators that we would say we'd have in supporting that. You're right in the fact that we can, if we change some of the energy and the requirement of operators, we can completely turn the design concept of a vehicle on its head, as we saw in that sort of last video, and that again can really change and have positive impacts not only in what it does every day, but how it protects some of our vital commodity.
Where's the boss? Have we got time for one more or not? Yeah.
Just a quick one. Looking at that, will those robot tractors have to be road qualified as well? Because they've obviously got to get to the fields, haven't they?
So the ones that are available today, it would be a standard tractor with a bunch of technology built on it. So again, it's not allowed to drive down the road, so there'll be somebody physically moving it. So again, that's maybe one of the challenges going forward of how do you, unless you're in a ring-fenced farm, how do you get the autonomous vehicle to where it needs to go? But again, there's some clever people trying to figure that out, I'm sure. So
And have a driverless lorry to take it there.
absolutely.
All right. Well, that's a fascinating insight into the future of machinery and also what is already happening on farm now. Please show your appreciation for Chris Wiltshire from John Deere.